So here we are provided with three numbers a, b and c. These three numbers are in geometric progression with the condition that all these values are positive and greater than 1. Now we need to verify that log of x with a base of a followed by log of x with a base b and then log of x with a base c. These three numbers are in harmonic progression for all positive values of x. So let us begin. So we'll start with a given condition. So here we are given that a, b and c are in geometric progression. So if they are in geometric progression, then we can immediately say that they are going to have a common ratio. So b, the second term divided by the first term, this ratio will be exactly equals to the ratio of this third term to that of the first term, which means we have b squared equals to ac. Now what we'll do, we'll take the logarithm on both sides. So we have log of b squared equals to log of ac. Now what we can do, we can apply the properties of logarithm. So whenever we have log of a raised to the power of b, so that's given by b times log of a, which means that on the left hand side, log of b squared can be rewritten as 2 times log of b. That will be equals to, then on the right hand side, we have log of a times b, the product. So this will be equals to log of a plus log of b. So in our case, since we have log of a times c, so this will become log of a plus log of c. Fine. Now here we will assume that each of the logarithm that we have taken on both sides, they have a base of x. So we have 2 times log of b with a base of x equals to log of a with a base of x added to log of c with a base of x. That's the common base. This can be also expressed as now the log of b with a base of x minus log of a with a base of x equals to log of c with a base of x minus log of b with a base of x. We are only rewriting the terms because the moment we rewrite in this particular fashion, this condition tells us that there is a common difference. So we can say that log of a with a base x followed by log of b with a base x and then log of c with a base x. These three numbers are in arithmetic progression. If they're in arithmetic progression, that immediately follows that they have a common difference. That's why we were able to come from this particular condition to the statement that these three numbers are in arithmetic progression. Now what we can do, there is a property of logarithm that says that if we have log of a with a base b, this can be also expressed as the reciprocal of log of b with a base a. So what we'll do, we'll take the reciprocal of each of the three terms. So the first one will become log 1 over log x with a base a. The second one will become 1 over log x with a base b. And then we have 1 over log c with a base x. So these three numbers are still going to be in AP. All we have done is we have just taken their reciprocal and rewrote each of the terms. Now in doing so, what we can say that if these three numbers are in AP, then they're reciprocal. Now we have to take the reciprocal of each of the terms. So reciprocal of 1 over log of x a, that's simply going to be log of x with a base a. Then reciprocal of the second term will become log of x with a base b. Reciprocal of the third term will become log of c with a log of x with a base c. So I made a mistake here. So this is actually log of x with a base c. So its reciprocal will become log of c. So its reciprocal will become log of x with a base c. So these are going to be in harmonic progression. So we have successfully showed that the three terms log x with base a, log x with base b and log x with base c are in harmonic progression.